This project consists of two components, watering and computer vision to monitor plant health. We'll first talk about the watering system. This is the watering system decision tree. Daily at 7 a.m. and 7 p.m. The system runs this algorithm to determine to water the plant or not. It first checks if there is rain by checking the soil moisture history log. Then it checks via NEA weather forecast via API to find out if it's going to rain. If both is false, it will trigger the watering. Or else, do nothing. Now let's look at the watering system. This video shows the watering system decided to water at 7 a.m. in the morning. Next we see that the watering system water the plant on user command via web application. Now we move on to the computer vision portion of the system. Here we see the layout of how the system is set up. The camera at the top is situated roughly 200 cm away from the ground. It is configured to point down towards the plants below. We will later see what the camera see. Here we explore what are the two flow of image capturing. First is registration. This step is done once by the user during setup. Is a simple 5-step flow of image capture, registration of reference point, color extraction, clustering and storage. Let's look at the registration flow in detail. Here we see an image of the camera view. This clip shows the user clicking on the different part of the leaves and marking them as reference point. This will give the system clues on where should the color extraction do the job. The system then uses the reference point to extract the pixels and generate baseline cluster. The colors you see now on the screen are just an example of one reference point. Then finally the color cluster is stored into the database along with the reference point. This does it for the registration process of the baseline. We'll now take a look at how the health check flow uses the baseline color to compare with live images. The flow is similar with registration where it starts with capture image. Then the system will use the registered reference point to extract color from the image. The same clustering program then cluster the color. The result is then compared with the baseline in the database. Now let's look at how it looks like. Periodically the system takes a picture for checking, the image goes through the same process of extraction. The extracted colors are then compared with the baseline colors for value difference. In this case none of the value difference is over the threshold. In this example, the image has a yellow leaf. It then goes through the same extraction and comparison. In this case, the color difference hits above the threshold. This will in turn trigger the system to send a notification to the user to inform the user that something is going wrong with the plant. So now what's the threshold that is used to compare? It's this number. But how is the number came to be? First, 30 images are chosen at random. Then for each of the 30 images, the reference point are extracted. Then all the pixels are inserted into clustering. Then the max and min of the cluster is gathered and the difference is calculated. After processing all 30 images, all the data is collated together. The table shows the min, average and max of the difference, then 80% of the max is used as the threshold for upper bound. To calculate color difference, the system uses HSV color space. Using hue is better because the color can be compared easily on a color wheel. For this example on the left, the first color hue is at 80 degree while the second color is on 82 degree. Their difference is only 2 degree. While on the right the difference can be seen to be at 46 degree. Now let's look at the different component of the system. On the left is the electrical controlled water valve, controlled by the Raspberry Pi on the right image, via the electrical controlled relay on the bottom right. On the bottom left there is the soil moisture sensor. Here we see the rough diagram of the system. The different sensors are connected to Raspberry Pi via its ports. The Raspberry Pi is connected to the server via Wi-Fi on the premise. The back-end server is hosted on the Azure cloud using Docker and VM. The user is then able to view the web application via their devices. Here we document some of the problem faced. During testing of image capture we noticed that one of the plant vein that was near the Raspberry Pi was moving. This in turn blocks the camera and interfere with the system. To fix this, the area around the Raspberry Pi camera is cleared. We also tested health check flow at different time and this caused problem as the color that is extracted is too different. To fix this we configure the system to only take picture at 2 p.m. Here's another problem where the plant moves because of growth. This 2 image we can see the plant moves in the time span of 3 weeks.